Hi, everybody. It's Professor Mitchell, continuing with Chapter 9. Today, we're looking at Section 9.3 on absolute value inequalities. The objectives in this section are to solve absolute value inequalities of the form absolute value of an expression is less than A, and to solve absolute value equations of the form absolute value of an expression is greater than A. The SLO for this section is to solve nonlinear inequalities. All right, so let's start with a little review of something we talked about in the last section. What is an absolute value? All right, hopefully you said a distance. All right, so let's talk about absolute value of an expression is greater than A. So this is a kind of silly analogy I made up many years ago. And it reminds me of this meme, "Dear algebra, please stop asking us to find your X. She's never coming back, and don't ask why." That part really puts it over the top for me. All right, but here's why this analogy reminded me of that meme. Suppose your X must stay at least 500 feet away from you. You are at 0, which means the distance between X and 0 is at least 500, which means the absolute value of X is greater than or equal to 500. So where can X go? Picture that on a number line. And I suppose what I could do is switch over to the tablet and draw a picture of this number line. So let's do that. All right, so here's the number line. Here you are at 0. So the question is, if the absolute value of X is greater than or equal to 500, where could X go? Well, X could go over here, right? That's at least 500 feet away from you. But X could also go over here, couldn't it? All right, and in this case, it says the distance is greater than or equal to 500, which means that 500 and negative 500 are both okay. All right, so from our work a couple sections ago in 9.1 on compound inequalities, this is a graph of the compound inequality X is less than or equal to negative 500 or X is greater than or equal to 500. All right, so let's go back to the presentation and look at our official rule for this type of inequality. And again, I call this the restraining order rule. That is a Mitchell term. So if you go to tutorial, don't say that you need help with restraining orders because they won't know what you're talking about. They might refer you to a lawyer. All right. Absolute value of X is greater than A. That absolute value inequality is equivalent to the compound inequality X is greater than A or X is less than negative A. Okay. All right, so we'll look at these examples. Okay, just want to make sure that was all of them. And we'll go back to the tablet. All right, here we go. Absolute value of X minus 9 is greater than or equal to 2. So there are a few things to check. First, check that your absolute value is isolated, like we talked about in the last section. And also check that the number on the right side is greater than 0. We'll talk later about what happens when that number is less than or equal to 0. And finally, this is a greater than or a greater than or equal, which makes it a restraining order. All right, so I am going to change this to x minus 9 is greater than or equal to, or the other possibility is x minus 9 is less than or equal -2. Once you have it rewritten in that form, it's very easy to solve. Just add 9 to both sides of this one, gives you x is greater than or equal 11. Add 9 to both sides of this one, gives you x is less than or equal to 7. So the graph of that compound inequality looks like what we were talking about just a moment ago. X could be over here, or X could be over here. The solution set for a restraining order type problem will always look like this. It will be the union of two separate intervals. So remember the way we write these in interval notation, it's going to go -∞, comma 7. And in this case, the 7 will get a bracket. Union, bracket 11, comma infinity. All right, let's look at the next example. The absolute value of x minus 1 is greater than 3. So what's different about this one is that the absolute value is not isolated. So I'm not even going to ask the other questions until it is isolated. I'm going to add 1 to both sides. That's going to give me absolute value x is greater than 4. So now it is isolated. The number on the right side is greater than 0. And it is a greater than or equal, which makes it a restraining order. And actually, in this case, there's nothing left to solve, right, except to rewrite it without the absolute value. It would say x is greater than 4 or x is less than -4, which on a number line looks like this. This time the endpoints are not included. So in interval notation, this looks like -∞, -4 with a parenthesis, union 4, comma infinity. All right, so the last example in this batch is absolute value 10 plus 3x plus 1 is greater than 2. This would be a good one for you to try on your own. Pause the video, try it, come back and compare notes. All right, so we will assume you have done that. The absolute value is not isolated, so I'm going to subtract 1 on both sides. It's going to give me absolute value 10 plus 3x is greater than 1. So now that the absolute value is isolated, 1 is greater than 0, and this is another greater than. I am going to rewrite it as 10 plus 3x is greater than 1, or 10 plus 3x is less than -1. So I'll subtract 10 on both sides. That gives me 3x is greater than -9. Divide both sides by 3. I get x is greater than -3. And on this side, I'll subtract 10 on both sides. That gives me 3x is less than -11. Dividing both sides by 3, I get x is less than -11 thirds. -11 thirds is -3 2/3. So it is just a little bit less than -3. Here's -11 thirds. Here's -3. Once again, the endpoints are not included. So in interval notation, this would look like -∞, comma -11 thirds, union -3, comma infinity. All right. So back to the presentation. Let's talk about absolute value of an expression is less than A. All right. So the analogy I came up with for this is house arrest. And here is another silly meme, cute ankle bracelets. Notice the one on the bottom. Okay, suppose X violates the restraining order and gets put on house arrest. X must stay within 100 feet of home. Home is at 0. So the distance between X and 0 must be at most 100 feet, which as an inequality looks like this. So where can X go? Let's look at a number line on the tablet. All right, so here's 0. Here's home. So if X has to stay within 100 feet of home, that means X could go this far in this direction or this far in this direction, right? Anywhere in between. All right, and it did say, I think, that it was allowed to be exactly 100 feet, so that would include these 2 points. And again, in section 9.1, we looked at inequalities that have solution sets that look like this, what we call a bounded interval. So this inequality is absolute value of X is less than or equal to 100. You can see from the picture that that has the same solution set as this inequality. Negative 100 is less than or equal to X is less than or equal to 100. All right, so the question with absolute value is always how to get rid of it when you're solving an equation or an inequality. And this is how you get rid of it in the case of what I call a house arrest. All right, so let's go back to the presentation, look at the official rule. If A is a positive number, then the absolute value of X is less than A is equivalent to the compound inequality negative A is less than X is less than A. All right, so we've got this batch of examples, which I will now switch over to the tablet. We can start looking at those. All right, so letter A, the absolute value of 5x minus 3 is less than or equal to 18. So let's notice that the absolute value is isolated. The number on the right-hand side is positive. And this time, the inequality is a less than or equal, which makes it a house arrest. Okay. It's very, very important to note whether each of these is a restraining order or a house arrest, because it's a completely different rule that gets applied depending on which one it is. All right, so we're going to rewrite this one as negative 18 is less than or equal 5x minus 3 is less than or equal 18. And we talked about how to solve this kind of inequality, not only in section 9.1, but also back in chapter 2. We looked at a couple of these. So I'm going to add 3 to all 3 parts of this, which gives me negative 15 is less than or equal 5x is less than or equal 21. And then I'll divide all 3 parts by 5. And that gives me negative 3 is less than or equal x is less than or equal 21 fifths, also known as 4 1/5. On a number line, this solution set looks like this. It's just the interval between negative 3 and 21 fifths. In this case, the endpoints are included. All right, and then in interval notation, it just looks like this. The solution set for a house arrest type problem is always a bounded interval. It has a real number as its left endpoint and a real number as its right endpoint. You won't see any infinity symbols with these. All right, on to letter B. Letter B is the absolute value of x plus 6 is less than or equal 7. Okay, and of course, in this one, the absolute value is not isolated. So I'm not going to bother asking the other questions. I'm going to just isolate it. So subtract 6 from both sides. That gives me absolute value of x is less than or equal 1. So now it is isolated. The number on the right-hand side is greater than 0. And it is a less than or equal, which makes it a house arrest. The absolute value of x is less than or equal 1 is equivalent to -1 is less than or equal x is less than or equal 1, which is just the interval between -1 and 1. And again, the endpoints are included. So that would be this interval. All right, and the last example, absolute value z plus 2 subtract 7 is less than -3. So if you happen to notice the -3 on the right side and that makes you feel uncomfortable, don't worry about it just yet because this absolute value is not isolated. So when you isolate it by adding 7 to both sides, now that number on the right-hand side is positive. So that gives me absolute value z plus 2 is less than 4, which is equivalent to -4 is less than z plus 2 is less than 4. All right, and to finish off solving that thing, I'm going to subtract 2 from all three parts, which gives me -6 is less than z is less than 2, which looks like this. It's the interval between -6 and 2. This time the endpoints are not included. And in interval notation, this thing looks like this. All right, so now I want to give you a chance to try some of these, and to make it a little bit more challenging, I'm going to do two things. First, I'm going to mix them all together. There's going to be some house arrests, some restraining orders, and there's going to be a few sort of weird situations. So notice it says be careful with the last 3. So when you're doing these last 3, you may notice that something is weird. And so I want to give you a chance to think about, in each case, what is the solution set of that inequality? Okay, so please pause the video and write down these 5 problems. Give them a try. And when you're ready, just come back and we will compare notes. All right, so here's the first one. The absolute value of 7 plus x divided by 2 is greater than or equal to 4. Notice that the absolute value is isolated and the number on the right-hand side is greater than 0, which brings us to the million-dollar question. Is this a restraining order or a house arrest? This one is a restraining order because the symbol is greater than or equal. So that means the rule, and if you're one of my students, I expect you to be able to solve these problems with the rule in front of you. So you don't have to memorize the rule, just know when to use it. 7 plus x over 2 is greater than or equal to 4, or 7 plus x over 2 is less than or equal to -4. All right, so I am going to multiply both sides of this inequality by 2. And I'll do the same thing over here. So that makes this one 7 plus x is greater than or equal to 8. Or 7 plus x is less than or equal to -8. All right, and then finally, I will subtract 7 on both sides. That makes this one 7, or x is greater than or equal to 1. Or x is less than or equal to -15. All right, so the solution set for this inequality looks like this. Remember, it's on the outside. Restraining order has to stay away. So in interval notation, the solution is -∞, -15 with a bracket, union, bracket 1, infinity. All right, next we have the absolute value of 7x minus 3, subtract 10 is less than or equal to -1. The very first thing I have to do is add 10 to both sides because this absolute value is not isolated. That gives me absolute value 7x minus 3 is less than or equal 9. So now the absolute value is isolated. The number on the right side is greater than 0. Is this a restraining order or a house arrest? This one is a house arrest because the symbol is less than or equal, which means we're going to rewrite it as -9 is less than or equal 7x minus 3 is less than or equal to 9. We'll add 3 to all 3 parts, which gives us -6 is less than or equal 7x is less than or equal 12. And then we'll divide both all 3 parts, by 7, which gives us -6/7 is less than or equal x is less than or equal 12/7. So this is all real numbers between -6/7 and 12/7, including the endpoints. So in interval notation, that solution set looks like this. Okay, so give yourself a hand if you got those two. And even if you didn't, give yourself a hand for trying. You'll get it, just takes practice. Okay, so now we get into the weird problem. So starting with this one, 8 plus the absolute value of x is less than 1. First of all, the absolute value is not isolated, so let's fix that. We'll subtract 8 from both sides. We get absolute value of x is less than -7. So the absolute value is isolated, but the number on the right side is not greater than 0. So we just kind of have to think logically about this. Remember that absolute value represents a distance. And this is saying that the absolute value is less than -7. In other words, some distance is less than -7. Well, what do all numbers less than -7 have in common? They're all negative. So this is saying the absolute value of x is negative. And that can't be. Absolute value of x can't be negative. So there are absolutely no values of x that will make this true. This inequality has no solution. Which, remember, we use this symbol for no solution. All right, that's it. Nothing more to do. Let's look at letter D. The absolute value of 4 plus 9x is greater than or equal to -6. So this time the absolute value is isolated. But once again, the number on the right side is not greater than 0. So you might be thinking, Mitchell, you just did that. The answer is no solution. Well, the difference is that in the last problem, it was less than. And in this problem, it's greater than or equal to. So that might be a different story. It's saying that some distance is greater than or equal to -6. So the question is, when is distance greater than or equal to -6? The answer is always, right? Because distance is actually always greater than or equal to 0. And all numbers that are greater than or equal to 0 are greater than or equal to -6. So what I would say here is distance is always greater than or equal to -6. So the answer is not no solution. The answer is at the exact opposite of that. It is all real numbers, which in interval notation is written like this. All right, and the very last example, the absolute value of 5x plus 6 over 2 is less than or equal to 0. So this one is saying that the distance is less than or equal to 0. Remember, less than or equal means just that. It's saying it's either less than 0 or it's equal to 0. Well, distance can't be less than 0. Can it be equal to 0? Well, yes, it can. Okay. So this inequality is going to have a very unusual solution for an inequality. It's just going to be one single number. Whatever number makes 5x plus 6 over 2 equals 0. All right. So believe it or not, this inequality will only be true when 5x plus 6 over 2 equals 0. So we'll multiply both sides by 2. Leaves us 5x plus 6. Subtract 6 from both sides. 5x equals -6. Divide both sides by 5. The only solution is just the single number -6/5. So for the first time in this section, we are going to write the solution set using curly braces, which is what we do when they're just isolated points. All right, and that is going to do it for section 9.3. We'll see you next time.